Batsabang Khabani. And like I told you yesterday, I'm going to be taking over from Grecian. So I hope today will be better, way better than yesterday. So yeah, so we're still doing differential calculus and we're still doing limits because it's the basic for calculus, differential calculus. So moving on. Okay. Okay, so just one more thing, you guys, for the new guys, you are all on mute, but I'll try to finish the lesson as soon as possible so that we can have a time for question and answers. So I'm just going to go through the slides, re-explain some of the things that we did yesterday, try to explain them better, because we're really going to use limits a lot in this chapter. So at the end of the lesson, today we'll be just focusing on one thing, just to determine the limit of a function. I know I gave you a homework yesterday, but I think there are certain things that we need to review first before we can do the homework. And I'll also help you with a few things on the homework so that you can do it. And then we start with the homework tomorrow. So with regards to the charts, I'll try to look at the charts while I'm presenting the session, but I think let's rather move a bit. Let's rather do work and then I can answer your questions afterwards. Okay. So today we'll be determining the limit of a function. So just an overview. The so the limit is basically the value a function approaches
and you can cook food at food and healthy eat and go and feed children. And when you feed this child at home, what about the parents? Because parents will be hungry also. That's why we are working with government. And from what the president has said, the 350, the additional to the social grant on children, all those resources are helping the poor families. So that's why we cannot say as a department we are going to feed children home. That share, we do not have the infrastructure to do that. Then another issue that is a challenge is our ECD grade R. And it's a fact that when we look at grade 12 and grade 7, we did not take grade R into consideration. We thought that grade R will come in as grade 1 comes to school. But what members are indicating here that the grade R is
Okay, we had a bit of a system error from our side. It was not connecting, so I couldn't share my slides with you anymore, guys. So can you hear me? Okay, great. So like I said, we're just gonna do an overview of limits. Let me just make sure that my chat is open so that you guys can tell me if you can't hear anything. Okay, good. So an overview of what we did yesterday. So yes, today we're just gonna determine the limit of a function. And then we're gonna do a recap from yesterday. So we're gonna start by defining what is a limit. So a limit is basically the value of y on a function, the value of as x approaches a certain value, which is our input, what happens to the value of y? And this is the notation we use. So if this is our function, if our function is f of x, if we want to check what happens when x approaches a certain value, in this case, which is a. So we're just gonna write the limit of the function f of x, as x approaches a is equal to that y value. But then what we did yesterday, so this is what I was basically explaining, the limit of f of x as x approaches a certain value, and then we check the L represents the values of y. And then the other thing that we did yesterday was to check the limit as x approaches a certain value from the left and from the right. So remember, this is from the left, which is represented by this negative. Let me just highlight that. So if we have this, the A negative just says from the left. So if you're approaching from the left, then this is how we represent our limit. And then if you're approaching from the right, let me use a different color. Oh, that's not a good color. Let's erase that. Let's use a different color. Yes, so we can just say this is from the left.
Ma'am,
Yes.
may you please zoom in?
Oh gosh. So you can't see you can't see the slides.
No, ma'am, I can't. It's too far. I can save, only that's how I should
Okay,
explain
let
it.
me try to use. Okay. So can you see now?
Yes, ma'am, it's better now.
Okay, thank you so much. So what I was just trying to show you is if you approaching from the left, we represent it with a negative sign on top. And then if we're coming from the right, this is from the right. I'm sorry about all the system glitches today. Okay, so if this is how you represent the limit from the left and the limit from the right. But what we concluded yesterday is that if your limit from the left and the right is equal, then we say the limit exists. Remember that. So you need to remember that. So it exists. So if the limit of a function from the left and right is the same, then we say the limit exists. Okay. So moving on, I just want us to recap from what we did yesterday. Okay, so if this was supposed to be part of your homework, but I just want to show you what I was expecting from you guys. So if you're asked to evaluate and illustrate the limit of a function, this is our function in this case, as x approaches pi. So what you need to do is to write the notation first. So you write, oh, I'm supposed to find the limit as x approaches pi, and my function is sine x. So you write the limit notation. And then the second step is to draw your graph. So because we know what the graph of sine looks like, we're just quickly gonna draw that, and then it will be something like this. But then we also need to do it because we are asked to find the limit. Remember, what we need to do is to find the limit. We need to find the limit. So what we need to do is to check, oh, what happens when I approach my value of y from the left and from the right at the point pi. So what I would do is check the limit from the left and right. Remember, our focus is on the y value. So if you look at the graph of y equals to sine x, when you approach this value, which is your x, remember this is your input. When you approach x from the left, it will look like this. Then you will have from your left. So this is from the left. So you will see when x gets closer and closer and closer to pi, the value of y gets closer and closer to 0. And then if you do the same thing, let's use a different color. So let's say we're coming from a different side, which is from our right. Yes. So if you're approaching, if your x is getting closer and closer to pi from your right side, your value of y is approaching 0. So what we can deduct from this is that the limit of sine x as x approaches pi. So our value of x is getting closer and closer to pi. Our value of y is getting closer and closer to 0.
Excuse me, ma'am.
Yes.
Why is pi in the center if pi is equal to 3.14? How is it in the center of the graph?
No, I didn't include all the graphs. So I'm just focusing on these points. So I just drew my graph for, remember, if you plug in the value of pi over 2 in this function, remember our function is sine x, isn't it? Do you agree?
Yes.
Okay.
Yes.
So if you plug in the value of pi over 2 in the function sine x, you will get a y value of 1, isn't it? But then if you plug in the value of pi in, if you type sine pi on your calculator, your answer will be 0. So it's not about what's in the middle. It's just that if you substitute your value of x with pi, what is your output? And your output is your value of y. Okay. So but then the other important thing, yes, that we need to remember, we were asked to find the limit of y equals to sine x. So when you draw a graph, you have to plug in, okay, what is sine of 0? Sine of 0 is 0. What is sine of pi over 2? Sine of pi over 2 is 1. What is sine of pi? Sine of pi is 0. What is sine of 3 pi? And then you connect the dots and then you have a function like this. But then another thing that you need to notice is that even if you drew your graph, you need to state whether the limit at this point or if our function at this point is defined or not. So how we check that is if you substitute the value of pi, do you get an answer of y? And we do. If you substitute the value of pi in your place of x, you will get 0. So in conclusion, okay. So in conclusion, we can say that the limit of sin x as x approaches pi equals to 0 and is defined at x equal to pi. It is defined because when we substitute the value of pi in this function, we get an answer. And how we represent defined is by showing a solid circle. Let me show you. So this point where your limit was approaching, you will represent it with a solid circle. So it has to be a solid circle. Hope that looks like a circle. Yes. So this is the defined part. So we're saying it is defined at x equals to pi because when we substitute the value of pi into our function, we get a value of 0. And we're saying that it exists because when you approach from the left and right, you get the same value. So let's look at a different example, also from yesterday. So let's say you're given this function. What I was trying to say is that, okay, you're given the function, you will factorize, and then this is the function you would think you would get to. But then, yes,
Sine pi over 2 is not equals to 1.
where do is your calculator in the right mode? Can you just check that?
Yes, it is, ma'am.
Unless if I'm
And sine pi either is not equals to 0.
no, it is. Can you just let me it is okay. Can we just quickly just go through the notes and then we'll get back to that? Because I just wanna make sure that we've covered everything for today and then we'll come back to that. But just check if your calculator is on the right mode.
Ma'am,
I'll get back to that.
ma'am,
Yes.
ma'am, I'm also getting, because like none of it is equals to 1 or -1. Even 3 times pi over 2 is not equals to -1.
Let me, what am I doing? Wait. Wait. Okay. Can you hear me, guys? So sorry about all these system glitches today. Let me try to share my screen again. And then you can just give me a heads up if you can hear me. Okay, let's go back to the sine function. Let me just open my chat quickly. Yes. So can you hear me? Okay. Remember when we're doing, let me just write a note. So if you want to use pi, which is equals to 180 degrees. Yes. So if you want to use, instead of using pi, you can use pi over, which is going to be 60 degrees. Yes. So pi over 2 will be 90, my bad. Yes, because 180 divided by 2 will be 90. So if you're on radian mode, so if you're using pi, your calculator should be on radian mode. So it's always important to check the mode on your calculator. Erase this. So your calculator should be on radian mode. Then you will get the answer. You will get the correct answer. And then with this one, you use degree mode. Okay, so, and then our conclusion is that the limit of sine x as x approaches pi is equal to 0. So our values of y are approaching 0 and it is defined. And then we show that, we indicate that by drawing a solid line, solid circle. But then, let's say in the case of this function. So if you're given y equals to y, the function is x squared plus 4x minus 12 divided by x plus 6. We know if we factorize the numerator, this is what we get. And if you substitute different values of x, you would probably get something like that. But then what you would notice is that at this point, so at x equal to -6, let me write this. At x equals to -6, if you take the value of -6 and you substitute it here, you will get 0 divide 0, which is undefined. So the correct graph, so the actual solution would have an open circle, which indicates that at this point, our function is undefined. But then our limit exists. So that's why we're saying if you approach x, let me show. So this is your x value. So this is x, the value that x is approaching. which is this part, and then the value which y is approaching. See, it's a different color. So, because this is our function, the value that y approaches would be the values of x. So we look at in this direction. So the closer you get to -6 from the left and right, these are y values. So the closer you get to -6. So if you substitute different values of x in this equation, you will get closer and closer to -8. But then if you substitute the value of -6, then you will get a value that's undefined. So that's why we say the limit exists, because when you approach from the left to right, you approach 8, but then it's undefined because it is not defined. So you don't get an exact value of y at this point. So at x equals to 6, we don't have, so there's no exact value of y. There's no exact value of y when you substitute -6. So do we understand this now? Okay. So if we were, so from what we've done so far, we can check if the limit exists or not by approaching the value of y from the left or right. But then there are points where let's say, for example, you are asked to determine the value. So this is actually an example from your textbook. Yes. So if you are asked to determine the limit as x approaches 1 of 10, our function, so 10 is actually our function. So let me write that down. So this 10 is our function. Yes, so the value of 10 is our function, but then we are interested in what happens when x gets closer and closer to the value of y. And then in the second one, we are asked, okay, if the limit approaches of x approaching 2 of this function. So this is also our function. Let me write. Is it a different color? So this is also a function. Okay, so this is actually our function, but the important thing that we need to check is to say, okay, what happens when we approach from the left? So if this is our function, so when we approach him from the left, okay, let's do it in the y value. So let's focus on the, let me erase this. So let's just focus on the y value for now. Okay, so our main focus will be on the y value. Yes, because remember, our function is what? If we look at it, our function is actually f of x. Let me note that down. Different color. So in this case, our function, let's call it f of x equals to 10, which is a straight line that goes through this value. And then in the second case, let's call this function g of x. X plus 4. So what you will notice is when you draw the function of x equal to 10, this is the function, and the function of our g of x, which is x plus 4, this is our function. But what happens when we approach 1? So the closer and closer we get to 1, this is our x value. Remember, this is our x. Now, what happens to our y value? Let's use a different color. Okay. So y will be that. Okay. So if x is approaching 1, y is approaching 10 from, so it's either left or right or top or bottom, so it's the same thing, but from different directions. So you can just say from different directions. So if you're coming from the top going down, your value of y is approaching 10, and from this different direction, it's approaching 10. That's why we say the limit as x approaches 1 of 10 is 10. And then if you have a function like this, which is x plus 4, you draw your function, and remember to show the solid line at this point to show that it's defined, because the value from the left and right is the same. So you indicate that by a solid line. And then the same thing with our g of x. We draw the function, and then we show, oh, okay, so what happens to the function when we come from the left and right approaching this value? So we also check the value of y. So as you approach 2 from this side, your value of y approaches 6. And then when you're coming from the bottom up, the closer you get to 2, which is our x value, your function actually goes to 6. So your limit exists and is defined at x equals to 2. The same thing with this one. It exists and is defined at this point. Okay, so if you have questions, so you can just also okay. So do you understand when we say the limit is defined and exists? Remember, when you draw a line, to know how your function looks like, you need to check, okay, if I substitute a value of 0 in this function, what value of y do I get? So, and then you continue doing that, and then you connect all the dots to get your function. So your function, the shape of your function, you get it from getting your input and your output. Yay.
So wouldn't the graph be defined at all points?
Yes, but then what I was trying to show you is that we have graphs where for example, in this case, it's defined at all points. I was touching on. Can you hear me? Hello? Sandy. Okay, so what I was saying is that how you draw your function is to check your input and output values. Then you plot them on your XY Cartesian plane, and then you connect the dots and you connect your points, and then that's how you get your function. So now, in this case, yes, your function is defined at all points and the limit exists. But then in the case of the other graph, but then in the case of this graph, you have hello?
Ai, yeah. Okay, sharp, yeah, so.
So yes, Ooh, I can mute him.
Yeah, Puma.
So you have functions where, yes. So you're just gonna do, oh gosh.
Sure.
Busiso,
Yes.
you you unmuted yourself.
Oh, I'm sorry.
Excuse. So yes, your homework will be, sorry about that, guys. Today is just one amazing day. But then you have functions where they are not defined at certain points, but the limit exists. So just because the limit exists, just doesn't mean that it's defined everywhere. So your homework is.
Aki.
Busisa,
Hello? No, it wasn't me. I think now they can unmute themselves to ask questions.
oh, okay. So yes, this is what you're still gonna do. As part of your homework, you're just gonna go through this. And then you check, for example, in this case, so let's say, for example, this function. If you substitute the value of 0, because your function is 1 over x, if you substitute the value of 0 in the place of x, you will get 1 over 0, which is undefined, which means your function is undefined at this point. So you do not have a value of y at this point. But then you can draw the function of 1 over x and check if the limit exists by checking from the left to right. What happens when you approach the value of 0? Because your function will look something like this. This is not going to be neat. This is your x, and this is your y. And then you'll have something. Ooh. Then you need to check what happens when you approach 0. Do you get to the same value of y? And then if you have the same value of y, then it means that limit exists. But then if you have different values, then the limit does not exist. So you can try that and then we'll do it tomorrow. Do you guys have any other questions?
No, ma'am.
No, ma'am.
No, ma'am.
Do we understand how we check if the limit exists or not, and if it's defined at a point or not?
Yes.
You don't sound convinced. Okay, I think the more we do problems, maybe we'll see how you check if it's defined or not, and if it exists, like if it exists or not, and if it's defined at a point. Because remember, the solid line dot means it's defined at that point. So just try to go through, because if you can also look at this, you can do it by inspection. You can just substitute the value of 2 here and then see which value you get. Can you see that?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, so hopefully tomorrow we won't have system glitches and everything will go smoothly. And then do you understand the part, because you were asking about the sign? So are you understanding this part, how you get
Yes, ma'am.
the pi over 2 and that?
Yes, ma'am.
Okay.
Now we get it.
Okay, then I'll see you guys tomorrow.
Okay, bye. Thank you.
Bye.
Thank you, ma'am.
Thank you. Thanks for your time.
Okay,
Sorry about all
bye.
the system glitches.
Bye.